Welcome to TechDaily.ai. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster AI servers, SA365, a turnkey security appliance, public and private cloud. You can check out stonefly.com for more info. So today we're diving into something pretty crucial in the cloud world. It affects, well, everything from app speed to your bills. We're talking about the big debate, serverless computing versus containers.
Yeah, it's a really fundamental choice these days, and our goal here is to kind of equip you with the knowledge you need. We want you to understand which way to lean, or maybe how to combine them for your specific needs. So we'll unpack what they actually are, look at similarities, differences, real-world uses, and we'll definitely tackle those tricky bits like the cold start issue everyone talks about.
All right, cut through the noise, get to what matters.
Exactly.
Okay, let's unpack this then. That term serverless. It trips people up sometimes, doesn't it? Like people hear serverless and think, okay, no servers at all. But that's not really it, is it?
No, not quite. That's a great place to start, actually. The real point of serverless isn't, magic no servers. It's that you, the user, you don't manage them. The cloud provider, they handle literally all the background stuff. Provisioning, scaling up, scaling down, maintenance, OS updates.
Security patches, load balancing.
Yeah.
All that.
All of it. Monitoring, logging, the works. It totally shifts your focus. Developers get to just write and deploy code, usually small bits of code, functions that react to events.
Events like an API call or someone uploading a file.
Precisely. Think AWS Lambda, Azure functions, Google Cloud functions. That's the core idea. Your code runs when needed, scales automatically, and you don't touch the underlying servers.
Okay, so that sounds pretty freeing for developers. No infrastructure headaches. But where do containers fit in? How do they compare to this no server management idea?
Right, containers. Think of a container as like a self-contained box for your application. It packs up the application itself, plus all the bits it needs to run system libraries, settings, dependencies, everything.
Like its own little self-sufficient world.
Exactly. And the beauty is, because it's self-contained, you can run that box, that container, on basically any machine that supports the container system.
So that's the portability aspect.
That's the portability.
Yeah.
And compared to, say, traditional virtual machines, VM's containers are way lighter. VMs virtualize the whole operating system. Containers just virtualize what the app needs, sharing the host OS underneath. Much faster, more efficient.
And you manage these with tools like Kubernetes, right? Or Docker Swarm.
Yeah, Kubernetes is the big one, but also Amazon ECS, Docker Swarm. Those orchestration tools help you manage and scale lots of these containers across many servers.
Okay, so they both definitely hide some complexity compared to managing raw servers or even VMs. What are the core similarities then, beyond just being more efficient?
That's a good point. They do share some underlying ideas. Both serverless and containers abstract your application away from the specific hardware or OS it's running on. That's key. Both also generally rely on orchestration for scaling. Serverless is often auto-managed by the provider. Containers you often configure more explicitly, but scaling is built in conceptually.
Right.
And fundamentally, their main job is the same. Deploy application code. Get your features out there.
Makes sense. Similar goals, different ways of getting there. But those different ways, they lead to really different operational models and different choices. Yeah. Let's dig into those key differences. Maybe start with deployment. How easy is it to get code running?
Good one. Deployability. Serverless, generally speaking, is simpler to get started with. Almost plug and play. You write your function, you upload it, bang. It can be live in milliseconds sometimes.
Wow, milliseconds.
Yeah. Containers, especially if you're using something powerful like Kubernetes, require more setup. You're defining things like namespaces, pods, how they connect. It's more configuration up front. Deployment takes maybe a few seconds, not milliseconds, but you get more control.
Okay, control versus speed there. What about maintenance, the day-to-day grind?
Huge difference. Serverless. The vendor handles all the server maintenance, the OS patching, all that infrastructure upkeep. It's off your plate.
Completely off.
Pretty much. With containers, you own the maintenance of your application's environment inside the container, and often the underlying host OS patches too, if you're managing the cluster yourself. You need to patch, update, keep things secure.
And where they can run. Containers seem more flexible there.
Definitely. Containers run on pretty much any modern Linux server, some Windows versions too.
Yeah.
Very flexible. Serverless functions are typically tied to a specific cloud provider's platform. AWS Lambda runs on AWS, Azure functions on Azure, and so on.
Which brings up that potential vendor lock-in issue we should probably circle back to.
We should. But first, let's talk cost. Because the serverless cost model, That gets a lot of attention.
Right, the pay-as-you-go thing. Why is that such a big deal for people?
It's transformative for certain use cases. You pay only for the compute time your code is actually running, down to the millisecond for some services. Think about it. If your function isn't being called, if it's idle, you pay nothing. Zero.
Okay, so no paying for servers sitting idle overnight or on weekends.
Exactly. Compare that to traditional models or even containers where if you don't manage it carefully, you're paying for those resources whether they're busy or not. Studies often show traditional setups have like 20–30% underutilization. That's wasted money serverless avoids.
And the cost per invocation is usually tiny, right? Like fractions of a cent.
Yeah, often something like, say, 0.20 some per million requests, plus a charge for the compute duration. It makes it incredibly cheap for low traffic or bursty applications.
But I've heard the flip side, too. If you have something running constantly, very high volume, can serverless actually end up being more expensive than containers?
Absolutely. That's the key trade-off. For really consistent, heavy, long-running workloads, a well-managed container setup can be cheaper, because that pay-per-millisecond model adds up if the milliseconds are always ticking.
So it's about matching the cost model to the workload pattern.
Precisely. Serverless also has basically zero upfront cost. No buying servers, minimal setup cost, great for startups or experimental projects. And the operational overhead is way lower. Less patching, less managing infrastructure means our team focuses more on code, potentially reducing staffing costs too.
Okay, cost is compelling. And you mentioned scaling earlier. This seems directly related. How do they compare when traffic suddenly explodes?
This is another huge win for serverless usually. It just scales automatically, based purely on demand. It can go from 0 invocations to thousands per second without you doing anything specific to configure that scaling. The platform handles it.
Like magic.
Feels a bit like magic sometimes, yeah. The resources just appear when needed and disappear when not. With containers, scaling is definitely possible, but you usually have to plan for it more. Configure auto-scaling rules, provision enough underlying server capacity. It requires more foresight and configuration, typically with Kubernetes or similar tools.
Got it. Effortless scaling versus configurable scaling. Okay, so we've covered some really strong points for serverless cost, ease of deployment, auto-scaling, but it's not perfect, right? Let's talk about the challenges. The big one everyone mentions is the cold start. What is that exactly?
Right, cold starts. So it's not really a bug, it's more like a consequence of the efficiency model.
Yeah.
When your serverless function hasn't been called for a while, or when it needs to scale up rapidly by creating new instances, there's an initialization delay the first time it's invoked. That's a cold start.
Because the platform shut down the idle instance to save money.
Exactly, to save you money. But waking it up takes a moment. This waking up involves a few steps. The platform needs to provision a container environment, start the language runtime.
Like Python or Java.
Yeah, and interpreted languages like Python or Node.js tend to start faster than compiled ones like Java or .NET, generally speaking. Then it loads your actual function code, resolves dependencies.
So a few steps before it can actually run your code.
Yeah.
How much delay are we talking?
It varies hugely, milliseconds to sometimes seconds in worst-case scenarios. While it might only affect, say, less than 1% of total requests typically, that delay can be noticeable, especially for things like user-facing APIs where responsiveness is critical.
Okay, so it's a trade-off for that pay-for-what-you-use benefit.
Yeah.
What makes these cold starts better or worse? What factors influence that delay?
Several things. Why they happen. Resource efficiency, like we said. Security, often a fresh, isolated environment is spun up. And autoscaling itself creates new instances. What influences the time it takes? Well, the runtime choice matters, like we mentioned.
Python faster than Java, generally.
Right. Newer runtime versions often have improvements too. Then there's packaging. How big is your code package?
If you upload a massive zip file with tons of libraries.
Exactly. Bigger packages, more dependencies. That takes longer to download and initialize. So keeping your deployment package lean is key. Prune unused stuff.
Right. Makes sense. Anything else?
Resource allocation. Giving a function more memory often implicitly gives it more CPU power too, which can speed up the initialization.
Okay.
And network configuration. If your function needs to connect to resources inside a private network, a VPC.
Virtual private cloud.
Yeah. Setting up that secure network connection, creating what's called an elastic network interface or ENI, adds a bit of latency to the cold start.
Right, like plugging in a network cable each time.
Kind of like that, yeah. A small but measurable delay for that secure connection setup.
So, given these factors, what can developers actually do to fight cold starts? Can we mitigate them?
Yes, definitely. There are strategies. One common one is provisioned concurrency. You
Okay.
basically tell the cloud provider, hey, keep X number of instances of my function warm and ready to go.
So you pay a bit extra to keep them running?
You do pay for the provision capacity, even if it's idle, but it eliminates cold starts for those instances. Great for predictable high traffic or very latency sensitive apps.
Okay. Any other tricks?
For some runtimes, like Java, Python.NET on AWS Lambda, for instance, there's something called Snap Start. It takes a snapshot of the initialized environment after the first cold start. Then subsequent cold starts can just load that snapshot from a cache, which is much faster than doing the full initialization again.
Oh, clever, like resuming from hibernation instead of a full boot up.
Good analogy. And crucially, observability. You have to monitor this stuff. Track that INIT duration in your logs. Look at overall invocation times, error rates, concurrency. You can't fix what you can't see.
Very true. Okay, so cold starts are manageable but require attention. What about other downsides or things to watch out for with serverless?
Well, testing and debugging can be trickier
How so?
because it's so distributed, right? You often have functions calling other functions, interacting with various cloud services. Replicating that exact environment locally for testing can be hard. And visibility into the backend can sometimes feel limited.
Right, debugging across multiple services sounds complex.
It can be. Then there are security considerations. Serverless introduces different potential attack surfaces, things like injecting malicious data into events, issues with authentication between functions, maybe misconfigured permissions, or vulnerabilities in the dependencies you include.
And that shared responsibility model you mentioned earlier.
Exactly. The provider secures the underlying infrastructure, but you are responsible for securing your code, your configurations, your data access.
And things like multi-tenancies. Multiple customers potentially running on the same physical server mean good isolation and security practices are paramount. Strong access controls, encrypting data.
Absolutely. Least privilege access, encryption in transit, and at rest. Standard best practices become even more critical.
What about tasks that need to run for a long time? Say, processing a huge video file. Is serverless good for that?
Generally, no. Most serverless platforms have execution time limits, maybe 15 minutes max. And since you pay per duration, a very long-running process could get surprisingly expensive compared to just running it on a container or VM where you pay for uptime.
Okay, so not ideal for those heavy, long batch jobs.
Not usually. And the last big one is vendor lock-in.
Ah, yes, we circled back.
Because serverless platforms often have unique features, specific APIs, ways of integrating services, you become quite reliant on that specific provider's ecosystem.
Making it harder to switch clouds later if you needed to.
Potentially, yeah. Migrating a complex serverless application built heavily on, say, AWS services to Azure or Google Cloud wouldn't be trivial. It's a strategic consideration.
Okay, that's a really good overview of the pros and cons, the nuances. So let's bring it together. How do you actually decide when should you reach for serverless and when are containers the better bet?
Okay, decision time. Serverless really shines for event-driven stuff. Think. An image gets uploaded to storage, trigger a function to resize it, a webhook comes in from a payment gateway, trigger a function to process it, IoT device sends data, trigger a function, that kind of reactive programming.
So responding to specific triggers.
Exactly. Also great for APIs and backends, especially REST or GraphQL APIs for web or mobile apps. Things like user authentication, fetching data from different sources.
Microservices, basically?
Yeah, particularly for those back-end microservices that might have variable load. And also for data processing, batch jobs, maybe scheduled tasks like nightly reports, log analysis, even some machine learning inference if the model isn't too huge. One-off scripts.
And the key pattern is often unpredictable or variable workloads, needing that instant scaling.
That's often the sweet spot. Scaling instantly from zero is a big serverless advantage.
Okay, so that's serverless. When do containers make more sense?
Containers are your choice when you need control. Complete control over the environment. Maybe you have specific OS level dependencies or need fine-grained tuning. Or maybe you're doing a lift and shift, moving an existing legacy application to the cloud without rewriting it significantly. Containers are often easier for that.
Right, package up the old app as is.
Pretty much. Also, for those really latency-sensitive services where even a potential cold start is unacceptable, or where you need custom runtimes, think high-frequency trading, maybe some real-time communication apps.
What about heavy-duty stuff like complex machine learning or video processing?
Yeah, things needing lots of predictable resources, maybe GPUs. Containers give you that direct control over resource allocation, video transcoding, big ML training jobs, maybe even some gaming workloads.
And compliance, if you have really strict rules.
Good point. If you need a heavily audited, hardened, predictable environment for compliance reasons, the control offered by containers can be essential. And just standardizing dev, test, prod environments containers excel at ensuring consistency.
So, stable, predictable workloads where control is key.
Generally, yes. Or when you absolutely need that environment customization.
But as you said earlier, it's often not strictly one or the other in the real world, is it? People mix and match.
Oh, absolutely. The hybrid approach is becoming super common. It's rarely black and white.
So how does that hybrid model look in practice?
You might use containers for your core stateful services. Maybe your main database runs in a container cluster, or a complex, long-running business logic service, things that are predictable and need fine control. But then you use serverless functions for the more volatile parts, like handling incoming API requests, processing uploads, reacting to database changes, running quick background tasks.
Kind of getting the best of both worlds. Control where you need it, auto-scaling, and cost efficiency where you can use it.
Exactly. You optimize each piece of the application with the right tool. Serverless for the bursty, event-driven bits, containers for the steady, complex core.
That sounds powerful, but maybe adds its own complexity, like managing costs across both models.
You hit on a key challenge there. Cost visibility in a hybrid setup can be tricky. It's harder to track exactly what's costing what when you have serverless functions potentially triggering container workloads, especially within, say, a shared Kubernetes cluster. Figuring out idle versus active costs in the container part can be tough.
So you need really good monitoring and tagging.
You do. Robust tagging, careful monitoring, maybe some specific cost management tools become pretty important to really understand where your spend is going in a hybrid world. It's a trade-off. More flexibility, potentially more complexity in tracking costs.
Okay, wow, we've covered a lot of ground here. We've journeyed through serverless and containers, looked at what they are, where they shine, their similarities, differences, and those tricky challenges like cold starts and costs. From that pay-as-you-go appeal of serverless to the deep control you get with containers, hopefully you listening have a much clearer picture now of how these technologies are shaping the cloud today.
Definitely. And thinking about all this, it really brings up an interesting question for the future, doesn't it? Given how fast cloud tech keeps evolving, keeps specializing, how is our very definition of infrastructure management going to change in the next few years? What does that mean for the skills needed by the people building and running tomorrow's applications? Something to think about.
A great question to ponder. And before we wrap up, just a quick reminder about Stonefly's special offer. They're offering 100 TB mutable and air-gapped SSO NAS for just $8,995. You can find out more about that at stonefly.com. Thanks so much for tuning in to this deep dive.